In this lesson, we're going to introduce trigonometric functions, or trigonometric ratios. And this is trigonometry, and trigonometry has to do with triangles, and specifically right triangles for right now. We can also use trig to help find measures of other kinds of triangles, but we're going to stick with right triangles right now. A and B in this picture are the acute angles of this right triangle, and C is the right angle of the right triangle. And so across from C, you're going to label that lowercase c, and that represents the length of that side, and that side is always called the hypotenuse. And across from capital A, all your angles should be capital letters. Capital A, across from that, you will call that little a, or lowercase a. And then across from B, you will call that little b. So sides should get lowercase letters and angles should get capital letters. The legs of the right triangle, which are the two that make kind of the L shape around the right angle, the legs are going to always be labeled when we're doing these trigonometric ratios as either opposite or adjacent. And opposite and adjacent can change depending on which perspective you're looking from. So if you're looking from the perspective of the angle A in this case, then we would label little a would be our opposite because it is opposite from the big A. And so if we're going from the perspective of big A or angle A, we would look at little side A as the opposite side. Then the side right next to big angle A is called the adjacent side. And so when we label these, we're always going to call the hypotenuse the hypotenuse. We're going to call the one opposite of our angle that we're focusing on the opposite, and we're going to call the one next to angle A the adjacent leg. And it's important to know that adjacent means next to, so if your angle is right here, actually there's two sides that are next to angle A or that make up angle A, but we can't call this one the adjacent because that one has to be called the hypotenuse. So you'll always know that the other one's the adjacent, even though technically they're both adjacent to angle A. But it's adjacent because it's next to angle A, and we're only talking about adjacent and opposite being the legs. The hypotenuse has to stay the hypotenuse. Now what trigonometric ratios do is they help you find either the angle that's missing or maybe a side that's missing. And if this isn't a special kind of triangle like a 30-60-90 or a 45-45-90 triangle, and we have some other kind of measurement for angle A, it's going to be the only way that we're going to be able to find information about the side lengths. And if we know the side lengths, we can go backwards and find the angle measures as well. But we're going to start with these three trigonometric functions. There's really 6 of them because there's reciprocal functions to these, but we're going to start with sine, cosine, and tangent. Now sine is abbreviated with 3 letters, S-I-N. Cosine is abbreviated with the 3 letters C-O-S, and tangent is abbreviated with the letters T-A-N, and all 3 of those are on your calculator. So you'll see sine, cosine, and tangent abbreviated with those 3 letters. And that's how we always will write them. We'll hardly ever write the full word out for any reason, but I wanted you to know how to say the words that are associated with these abbreviations. And finally, the way you'll write the trigonometric ratio is like this. You'll take the trigonometric ratio, which will either be the words sine, cosine, or tangent, but I'm going to make this one generic so that it fits for all. And then you're going to take that trig function of an angle. So next to the sine, cosine, or tangent is always going to be an angle name or an angle measurement. And then you put equals, and here's where the ratio part comes in. You're going to put a side over a side. It's a ratio of sides. A side over a side is a fraction. And so you're going to always keep these two together, trig of an angle, trig function of an angle, equals side over side. And it's important to know that angle always goes here, and sides always go on the other side of the equal sign. And so an example would be, you could say sine of angle A equals little a over C, or something like that. And we'll talk about how you know which sides go with which trigonometric functions on the next slide. But you'll say sine of A, that's the trig function that you're doing to the A, and the ratio of that is A over C. And the little a and the little c represent the side lengths, which might be inches or centimeters or miles or something like that, where angle A will either be measured in degrees or radians. And most of the time, when you're first introduced to this, we'll stay with degrees. And then as you go further into trig, you'll start calling them radians, which is just another kind of angle measurement. A very important word that's just an acronym that you need to remember for trigonometry is Sohcahtoa. That word will take you a long way. And Sohcahtoa is spelled in red at the top of the slide, but what you're looking for is what they stand for. And this particular part, the so, means that sine of your angle equals opposite over hypotenuse. So sine is opposite over hypotenuse. Then the next one is cosine of the angle equals adjacent over hypotenuse. Cosine is adjacent over hypotenuse. Then the next word we're looking at, toa, stands for tan of an angle equals opposite over adjacent. So tan is opposite over adjacent. And I said to label the sides according to whose perspective you're coming from. So say that they gave us, they wanted sine B or cosine B or tangent B. That means we're coming from the perspective of angle B, and we would label this as hypotenuse because it's across from the right angle, which is always a hypotenuse. And then we would label the one across here opposite, because it's opposite of angle B, which is the one we're talking about. And then the one right next to B is called the adjacent. And once you label that from B's perspective, that needs to stay that way while we're talking about angle B. So if someone was to give you the side measures and we wanted to find sine B, they asked you to find sine B, you would just put the opposite side over the hypotenuse side. And notice I've labeled those with numbers, so the numbers were given and the angle was not given, and so we can still find out what sine of B is. It's 4/5. So one way you might use the trigonometric ratios that we've learned so far is if you know an angle of a right triangle, and oftentimes you know the angle, and a lot of times these are application problems, and for some reason you're given one of the angles and you know that the other two lines are a horizontal and vertical line which make a right angle, and so you end up with a picture maybe something like this. And you're asked to find what is the length of x or what is the length of y. And you can find that as long as you have one angle and one side, you are able to find the other information. So what we want to do is set up something that we know is true about this triangle using sine, cosine, or tangent. And first of all, we want to label. So if we're going to go from the perspective of the 55-degree angle, then opposite would be there and adjacent would be this one right next to it. And then this one has to be the hypotenuse. So we're going to call this one the hypotenuse. This one is the opposite from the 55-degree angle, and this one is adjacent or next to the 55-degree angle. So once you get them labeled, then everything will kind of fall into place with Sohcahtoa. So what we want to write is that we want to choose whether we want sine, cosine, or tangent. So let's say we're going to find x first. So that means we're dealing with the hypotenuse. So if you think of what Sohcahtoa looks like, there's only two things that involve hypotenuse, and it is the sine and the cosine involve the h, or the hypotenuse. And so we have to choose one of those to use. Well, it wouldn't help us to choose the opposite because we don't know anything about the opposite number-wise. We just have a y there. So it would help to use the adjacent because we have a number there. And so we want to do something with the hypotenuse and the adjacent, so we look for that in our Sohcahtoa, and we have adjacent, and hypotenuse in cosine. So we're going to write cosine of the angle. Remember, you always take cosine, any of your trig functions, of the angle equals the adjacent over the hypotenuse. So adjacent comes first and hypotenuse comes second. When x is on the bottom and we need to solve for it, what I tend to do is take this, if it's not already a fraction, and make a fraction on the other side, because then if we can cross multiply, we will be able to rewrite this with x not in the denominator. So I'm going to cross multiply this way first and say that that's x times cosine 55, and then equals, and then we cross multiply the other way, and it is 1 times 24, which is 24. Then the last step will be solving for x, which means since it's connected to cosine 55 with a multiplication, we want to divide out the cosine 55. Cosine 55 goes together. You don't separate those. That's one thing right there, cosine 55, and so we want to divide that out on both sides to get rid of it and get x by itself. And what that does is it causes this cosine 55 to cancel with this cosine 55, and this can be done on the calculator if you need an approximate answer. Sometimes they like you to leave it as that kind of fraction, but if they were to wanting to know approximately, rounded to the nearest tenth, what is the side length x, you would do this in your calculator, 24 divided by cosine 55. One thing you want to make sure is in the mode setting of your calculator that you have it set to degrees, not radians. In this particular example, we're dealing in degrees, not radians. So you can check the mode section of your calculator and make sure degrees is highlighted. So when I divided that on the calculator, I got 41.8, and that could be inches or centimeters or miles or whatever the question calls for. But that is the length of the side that's labeled x. Then for the same problem, we may need to know what length y is for some reason. So we are dealing with opposite, and I tend not to use the one that I just found because it's rounded off. I would still prefer to use the exact 24 that we had to begin with. And if we're dealing with opposite and adjacent, we go to our Sohcahtoa and find out that opposite and adjacent are found in the t, the toa part, so that we're talking tangent. So what you would write is that tangent of 55 degrees, those always go together, equals side over side, which is opposite over adjacent. So opposite is y, adjacent is 24, and that comes from tan being the opposite over the adjacent. And since one side is a fraction, I'm going to go ahead and make the other side look like a fraction so I can cross multiply. And it ends up that is 24 times tan 55 equals 1 times y, which is just y. So we already have y solved for. We don't need to divide by anything like we did down in the last problem. We had to divide by cosine 55. We already have what we need to put in the calculator right here. And if they wanted the exact answer, you could just say 24 times tan 55, and that would be okay. But if they want an approximate answer of the length of that side, we're going to need to put it in the calculator. And it looks like y rounds to 34.3. And that is the length of the side that's labeled y. So that's how you use trig functions to help you find missing sides.